Welcome to the lecture. Today we will discuss what is Radix-2 FFT. Last time I have told you what is FFT and we derived this formula in the last video or lecture, and we have seen the example of 8-point DFT and we converted that 8-point DFT into 4-point DFT. Now, what was the advantage of this? If we divide 8-point DFT into 4-point DFT, what will be the advantage? In the last video we have seen, in this case, if we have n is equal to 8 and what will be the number of multiplications? In this case, multiplications will be n square, that is 64. We divided this 8-point DFT into 4-point DFTs, and in this case n has been divided into 4, so number of multiplications will be 16, and having this one multiplied by 8 components, or so the total number of multiplications in this case we found 16 plus 16 plus this factor that has been multiplied by odd components. So if we further divide into 2-point DFTs, what will be the result? From this we have n is equal to 2 and multiplication 4. So total 16 plus this, and in this case is been multiplied by 2 component, 2, so total 8. If we divide this 8-point DFT into 2-point DFT, the number of multiplication has been reduced to 24 from 16. So if we want to generalize, or we want to see the general relation between DFT, higher value DFT, and Radix-2 FFT. So if we have n samples in time domain and we apply DFT directly on that, we will have n square multiplications, and instead of applying DFT, if we apply Radix-2 FFT, it will come out to be n log base 2, and as in this case we have n is equal to 8, so number of multiplication in FFT would be 64. But if we apply this Radix-2 FFT, it will come out to be 8 into 3 is just 24. So 64 will take a lot of time to process, and the processor will take much time, much power, and it will be costly, it will be very slow. So instead of doing 64 multiplications, if we have just 24, so it is effective, cost effective, fast than this 64. So if we have this x of n, so what is the simple way to convert this signal into 2-point FFT? indexes of 2 point. Suppose I have this signal and I am assigning the binary numbers to each sample. In the previous lecture, we divided this into 4-point DFT. Interlaced decomposition, just write even 1, 2, 1 and 1. The rest of ones were odd like this. Now in this case, if we further divide into even outputs 1, 1, 2, 1, minus 1, minus 1, 0, 3. What you observe from this? This is 0, 0, 0, just the first case. This one is, what is this? This one, 1, 0, 0. This two, 0, 1, 0. This one is there. And next, this minus 1 is this one, 1, 0, 0. Similarly, 0 is there for that. So what we observe from this, if we have this x of n and we want to find 2-point DFT and we want to divide into this signal by using interlaced decomposition, we will just have to reverse these bits. We assign binary numbers to each sample ascendingly, and if we reverse this just like this, 001 has been replaced by 100, we will get 2-point DFT interlaced decomposition. So just giving you an idea how to convert this directly. Suppose we have this signal and we want to find FFT using Radix-2 method. Just reverse the bits, it will be same like this. In the next case, it is this one. This will be same. This will come out to be this. This will be -1. This will remain same. This will 0. So in this case, what we have to do is just to apply 2-point DFT. In 2-point DFT, this circle comes into play, and we have to divide this circle into just two parts, 1 minus 1. If we want to apply this 2-point DFT into these two, suppose x of n is equal to 1, 1, and we have just x of k is equal to x of n e power minus j 2 pi k n over n smash n approaches to 0 to n minus 1. Just in case of 0, I said add both values. If we have 1, in this case x of 0 will come to and 1, and the value of e will be reduced to minus j, because we have n is equal to 1, k is equal to 1, and this is j pi. At that point we have just, this is 1, this is minus 1. So what we conclude is, the simple result is that we will have to make these butterflies, and what we'll have to do is just add first and then subtract both. We divided this circle into two parts: 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1. In the first case, first time just add both. If we add, it will come out to be 2, 0, add both, 3, 2, 1, 3, 1, minus 2, 0, 3, minus 3. This is only the 2-point DFT. So we want to find now 4-point DFT. Is just make this one. If you are applying 4-point DFT, what you will have to do is just divide this circle into 4 parts. We will have to just multiply this. 1 minus j minus 1 j, 1 minus j minus 1 j. So in the first case is just 2 minus 3. It will come out to be minus 1. It will come out to be 2 plus, this is 1 multiplied by 3 is 5. Similarly, next one, minus j minus 1. In this case, 0 spread in j. In this case, 2 minus 2, 1, 3j minus 5, and in the last we have just 0, 3j. It is minus 3 into minus 3. Yes, this one. 0 straight And the next step, what we'll have to do is just expand this. Now we want to get the 8-point DFT. In this case, we'll have to join fourth. In the reverse order, we will like this. These arrows show the odd one. In this case, you will have to divide the circle into 8 equal parts. First one, 1, that is 0.707 minus j.707, and then minus j minus 0.707 minus j.707, then minus 1, then it comes out to be 0.707 minus plus j.707j and 0.707 plus j.707. In this case, you will have to just apply again the same thing. File will be straightforwardly moved to the place, and the next one is been 1 multiplied by 1, 6. Similarly, next one, just calculate the values. I have some values here. I just want to write it. 2.121 plus 1.121j just use the same procedure, drag j sample minus j to there, and this is 3j, multiply 3j with this one, and next value I have is minus 1 plus j5. Again, the next one is minus 2.121 plus 3.121j. The next one is 4, and next one just conjugates conjugate of this. So this was the FFT, Radix-2 FFT. What we have is just I have x of n in the time domain as 1, minus 1, 2, 0, 1, minus 1, 1, 3, and x of k in frequency domain is 6, 2.121 plus 1.121j 3.121j 4. So if we conclude this, I have 8 point DFT. Sorry, 8 samples in time domain. And if I want to calculate DFT directly, I will have to use the long lengthy formula of DFT, and it will take a lot of time. So if I apply Radix-2 FFT, you have seen, just you divide the first time circle into two parts, and you just add subtract 2 points, add subtract, add subtract, add subtract, and then just you divide circle into 4 parts, multiply with the 4 sectors, then you divide the circle into 8 parts and just multiply the values according to the formula, that is multiply and add the value. E of n plus W of nk O of n. So this circle, I have explained this circle in detail in the previous lectures, is giving the W of nk, that I was writing these values. These were basically W of nks. So we can easily calculate FFT, Radix-2 FFT. So that's it for today's lecture. In the next lecture, I will tell you how we can find IFFT using the same Radix-2 method.